So if we get to lymphopoiesis, then of course we got again a common lymphoid progenitor. And yeah, we can simplify it to lymphoblast. But what's the big difference? Well, the hematopoiesis over here, the lymphopoiesis, that only the early stage of lymphopoiesis happens in the bone marrow, okay? And we should already divide it to T and B cells because there's a slight or maybe bigger difference. So B lymphoblasts and T lymphoblasts. Okay, so, and because of these two, then we have to jump to the other organs where they mature. So typically immature B and T lymphocytes, they leave the bone marrow. They are not fully developed. They are still not naive. They are not matured fully. And if we talk about T lymphoblasts, then of course we have to imagine thymus. So this is a now chest, and this is a thymus. And the difference between a T and B line is that actually, if I would compare it and maybe think of how many divisions and how much they maturate in the other organs out of the bone marrow. So in terms of thymus and T lymphoblasts, they mature, I would say, longer or in more phases because, for example, the VDJ recombination happens in the thymus, okay? So T lymphoblasts and whatever precursors or we could say it's some kind of a prolymphocyte, they travel to thymus. And for example, the VDJ recombination happens over here, okay? And they wait over there, they mature over there, and at the end, they come out as a naive T lymphocyte, okay? That's the T lineage. With the B lineage, or with the B lymphocytes, the VDJ recombination still happens in the bone marrow. And then the pro-lymphocyte, or the precursor, whatever you want to call it, travels to another organ. And the organ is called spleen. Okay, so we got a big spleen over here. I'm going to draw artery, and I'm going to draw a vein. And the still immature B pre-lymphocyte travels to the white marrow of the spleen, where it goes like through two phases and finally matures over here, okay? So still it's immature when it leaves the bone marrow, but still basically there are only like two phases till it's fully mature. But anyways, first of all, watch out, spleen is something totally or much different and much more complicated than a normal lymphoid node. I'm going to draw a lymphoid node over here, small one, okay? So watch out. And the main difference between a lymphoid node and a spleen is that spleen filters blood. And I mean, blood goes there and gets out. In contrast to this, lymph nodes, it's about lymph. Okay, so lymph is filtered with the lymph nodes, okay? And some students say or talk about spleen as a sort of a big lymph node. That's not true. It's much more complicated organ and it has many functions. One of the main function is the maturation of the B line, okay? But also it filters, all the blood elements, so erythrocytes, platelets, and it's a place of destruction of all the elements. And not only that, but also it's a very important organ which fights bacteria, typically encapsulated bacteria that are present in the blood. So if you have a sepsis or if you have a bacteria present in the blood, that's the place of first fight, okay? Or very commonly, the most important place where the bacteria typically are destroyed, okay? And we're talking about pneumococci, we're talking about Haemophilus influenzae, we're talking about meningococci like Neisseria meningitidis. These are capsulated. Okay, and there's a bit discrepancy, especially with the spleen. What do we call in terms of primary and secondary lymphoid tissue? Okay, so what is primary tissue? Well, primary tissue, and it's very simple. If it's a primary lymphoid tissue, what do we talk about is bone marrow. So this is primary lymphoid tissue. These two. So it's thymus and a bone marrow, okay? And everything else is a secondary lymphoid tissue. So in primary tissue, that's the place where all the lines, and over here, as you can see, with myelopoiesis, we don't have a problem because everything matures in in the bone marrow. But with the lymphopoiesis, we got a problem because something matures the final maturation is done out of the bone marrow. So, but thymus and bone marrow are then taken as a primary lymphoid tissue. And now we have a problem with spleen because, yeah, as I told you, in spleen, final maturation of the B lymphocytes or B lineage happens over there. But not only that, okay, also a activation, the same as, let's say, or very similar, or there are different kinds of activation, but also in another way, it behaves as a secondary lymphoid organ. So basically, if I would like to define like the difference between a primary lymphoid tissue and a secondary, maybe I should take the definition of the secondary lymphoid tissue. And that is the place where the activation already of naive T and B lymphocytes takes place. And this would also take in account the spleen, okay? So what happens in the spleen is, on one hand, the lymphocytes mature over there, but on the other hand, they are also waiting over there for activation, okay? So if the ultimate rule is that the secondary lymphoid tissue is the one where the naive B or T cells will get activated, then it's a secondary lymphoid tissue. So we take spleen and everything else, so of course, lymph nodes and everything with that, so that means also the MALT system, which encompasses GALT, BALT. GALT is with the intestines or gut, BALT, that's bronchi. SALT would be with the skin, VALT would be vulvovaginal. All these are different types of MALT, which is a mucose-associated lymphoid tissue, okay? So all these places, they're taken as a secondary lymphoid tissue, okay? And I'm still going to go through and this is a lymph node over here, lymph node. Or watch out, still the term organs and tissues. So basically, term organ, primary or secondary lymphoid organ, we take it if it's, and watch out, bacteria can be encapsulated, but also organs. If organs has some kind of a capsule, like a lymph node or an appendix, which appendix is a part of that's appendix over here. It's a part of and I forgot, of course, NALT. That's going to be, that's a nasopharyngeal system. And this one, of course, takes account also tonsils. So, and adenoids, okay. And over here, yeah, we talk about tissues or organs. The ones which are like encapsulated, you call them organs. The other ones are like rather, if they're in mucose, like spread it, you call them tissues, okay. So appendix, you can call a organ, like secondary lymphoid organ. Tonsils as well, for example, Peyer's patches, that's a rather tissue. Over here, you can, of course, don't forget Waldeyer's, like circle. So those are the tonsils and everything. So anyways, that's the mucosa-associated lymphoid tissue, all of them, okay? So all of these are taken as a secondary lymphoid tissue. Okay, so we got a primary, again, primary, that's thymus, and then bone marrow, and secondary, that's everything else, okay? Even the skin. If the lymphocytes are in the skin and they make some patches over there, it's a secondary lymphoid tissue. Anyways, so in terms of T lineage, the final maturation is in thymus. In terms of B lymphocytes, the final maturation happens in the spleen, okay? But still, of course, after that, then the T lymphocytes, they travel to all different places. They travel to skin, they travel to spleen, they travel to the lymphoid node over here. You know that we got a paracortex. That's where the paracortex, that's where the T lymphocytes wait. Naive wants to be activated. Then you got a follicle over here that's full of the B lymphocytes, naive B lymphocytes that are waiting for activation. Okay, and when the antigen comes and they're activated, of course, it changes. The primary follicle changes into secondary follicle. You know, you got a germinal center over there. And what else you got there? Well, so in cortex, this is a cortex, This is a cortex. You got rather B lymphocytes. In paracortex, you got T. Okay, so B ones, you got T. But watch out, of course, you got also histiocytes, or in other words, you got that's medulla over here. Medulla. And you can call them histiocytes, or maybe better term nowadays is macrophages. And you got macrophages over here in the medulla, and basically they work as a scavengers or whatever as the lymph goes through and this is the way out for the lymph. This is the entrance of the lymph flow So basically, the macrophages, they're the ones which get rid of all the debris, all the, let's say, apoptotic remnants and whatever, and also bacteria. So if they go through the lymph node, that's the last place where they could be filtered, like the last gate before they let it farther, okay? But not only that, also don't forget, you got the tingible macrophages already waiting in the follicle, okay? So the tingible macrophages that are within the follicle, and actually their action is typically when the B lymphocytes get activated. So it depends how much they react to the antigen. If the affinity of the antigen is not enough, they will turn apoptosis, they will destroy themselves, and these macrophages will get rid of the debris, okay? So don't forget, these are special type of macrophages that are located in the follicle, okay? So in the lymph node, you got T and B lymphocytes, but of course you have some cells from the myeloid lineage, and also don't forget you got the dendritic cells as well over here. So antigen presenting cells, whatever. Okay, some dendritic cells and other ones. Okay, what is interesting, normally in the lymph node, you shouldn't have a neutrophil. So normally neutrophils, or I won't write it, but neutrophils or eosinophils or basophils, they're not normally present in a normal lymph node. They can get there if there's a bacteria, whatever, but normally you don't find them there. That's not typical, okay? So this was just to remind you the myelopoiesis and lymphopoiesis, okay? What are the primary and secondary lymphoid organs and how they divide? Still one comment on spleen. So spleen is a very important organ in many ways, in maturation of the B lymphocytes and also getting rid of the old particles, blood particles as erythrocytes and platelets, but also fighting A bacteria that are present in the blood. I mean, the T lymphocytes and B, they will get directly activated. Their waiting there is naive and they will be directly activated by their antigens. Problem is when you lose spleen, okay, and this is typically due to accidents and whatever, car accidents. So if you're having a car accident and there's a rupture of the spleen, you can have a serious, and you will have a serious bleeding leading to shock. So at this time, it's very urgent. You have to get rid of the spleen so the patients undergo splenectomy, okay? And in case of splenectomy, obviously, now you're losing in case of splenectomy, now you're losing a very important organ for B line maturation. So what will happen? The B lymphocytes, the still not fully mature lymphocytes, they will mature in other secondary lymphoid organs as nodes and whatever. But unfortunately, this maturation is not optimal. So basically, everyone who loses spleen is a bit immunocompromised, okay? And especially against these encapsulated bacteria. But not only that, also other viruses and whatever. So what you have to do, you have to vaccinate these people, okay? So every time someone loses a spleen, they have to be fully vaccinated, and typically against pneumococci, meningococci, okay, and the ones I mentioned, also against flu every year, okay, against flu, of course. Yeah, so don't forget, the spleen is an important organ, and you need to be vaccinated in case you don't have it. Also, there are planned splenectomies, okay? For example, in terms of, splenectomy, so vaccination, very crucial, vaccination, okay? So all of them have to be vaccinated. And in case of splenectomy, planned splenectomy, which you can do, it's sometimes done, for example, in immune thrombocytopenia, which is a typical immune process that destroys your platelets. Typically in older women happens, also in children, but in the older woman it's more severe. And in this case, if nothing works, the only solution is a planned splenectomy. And when you get rid of the spleen, then the number of thrombocytes increases. Well, in this case, if it's planned, then of course you first vaccinate the person, then you wait like 2 months, and then you take out the spleen, okay? So if it's planned, you vaccinate first, then you take out the spleen. So this was just to remind you the lymphoid tissue and also the importance of spleen and how the lymphocytes maturate, okay? So let's get to a third one. Okay, so now a very important principle. I'm going to put 100%. So thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.